Operations in our applications will commonly involve multiple data types. Because of that, we have to deal with type conversions. Now, there are implicit type conversions, and those are type conversions that are performed automatically by the compiler. To see a simple example of that, we look at something like here. We have an integer ival that we've assigned the value 50. If I then say long lval equals ival, the compiler has to convert that 32-bit integer ival into a 64-bit integer as it's stored into lval. And there are also explicit type conversions, and these are conversions that I explicitly perform in my code. And I do that using a cast operator. We see here if I have that long lval equals 50 now, so I'm now assigning a 64-bit integer the value of 50. If I want to assign that into this ival, a 32-bit integer, I have to explicitly cast it. I have to tell the compiler that I want to go from that 64-bit integer into a 32-bit integer. And I do that by using the type I want to convert to, in this case int, putting it inside of parentheses and putting it next to the value I want to cast. So this says, the int in parentheses says, take the lval and cast it down to a 32-bit integer. If we look at these implicit type conversions, these are generally what we call widening conversions. And these can be done automatically because we're moving to a wider data type. So if I have a 32-bit integer and I want to move to a 64-bit integer, that's wider, right? So the values can be safely moved, so those can be done implicitly. And the compiler has to make decisions about how to make these conversions. And the rules are pretty straightforward. If I have an expression with multiple integer sizes in it, right? Maybe I have a short and a long. Whatever the largest integer size is what things will be converted to. So if I do an operation with a short and a long, the short will be implicitly cast into a long. If I perform an operation with mixed floating point sizes, so I have a float and a double, it'll always go to the double, right? Because double is the largest floating point size. And then if I have an operation that uses integer types and floating point types, the compiler will cast to whatever the largest floating point in the equation is. Right, so if I do an operation with a long and a float, the long will be cast to a float. If I do an operation with a long and a double, the long would then be cast to a double. Explicit type conversions are the ones that we explicitly perform in our code, right, using this cast operation. When we do that, we're taking responsibility for whatever happens as a result of that type conversion. Because of that, we can perform both widening conversions and narrowing, right? So widening going from a 32-bit to say a 64-bit, narrowing going from a 64-bit down to a 32-bit. We should just want to be aware though that we know what could potentially happen. Right? If we do an explicit cast from a floating point to an integer, well, floating points can have fractional portions, integers can't. So any fractional portion would be dropped when I cast that float down to an integer. You want to be careful when performing a narrowing conversion. Right? If I have a 64-bit integer, it has the ability to hold values that are too large to fit into a 32-bit integer. So if I cast that 64-bit to a 32-bit, the program will actually do it, but if the value is too large to fit into a 32-bit, you'll get some odd results from that. So you want to make sure that when you're casting it, doing a narrowing cast, that you know that what you're doing is safe. And the last one is just that you want to be careful when converting from an integer to a floating point. Because if you have an integer with a large number of significant digits, because of the way floating points are stored, you could lose some of those significant digits. The deep details of how these type conversions occur are beyond the scope of this course. But if you'd like to understand them in more detail, I've got that URL on the screen for you that actually points to the Java documentation that talks about those details. If you check that out, you'll particularly want to look at the sections on widening primitive conversion and narrowing primitive conversion.